Gradient Jacobian Tensor Matrix. So we are proceeding in gradient Jacobian and tensor matrix. What we have learned till now. Okay, so Okay, so this discussion is about uh, up, up. Jacobian. I think okay, it is Jacobian, Hessian, and tensor matrix. Okay, so we are proceeding in discussion about Jacobian, Hessian, and tensor matrix. Okay, what is Jacobian and what is Hessian and what is tensor? I believe it is quite clear now. Jacobian matrix is equivalent to single derivative in single independent variable case. If someone has single independent variable case, that is x-axis, and dependent variable case is y-axis. X-axis, y-axis. Y-axis is also called function over x-axis. Means if this is x-axis, this is y-axis. Above the x-axis, I am drawing one single curve in y-x plane. And that single curve has an equation function over x. Equation means at any point on x-axis, x equal to x. If I draw a vertical line, it will hit the curve at a point called x comma fx, where fx is the height and x is from the origin. This height is fx. Since function over x is variable with the x, this is called the equation of the curve. At any moment, if I want dfx by dx, then it will come as Jacobian matrix in multiple variable case. At any point, if I say d2fx by dx square, it will become a Hessian matrix in multiple variable case. At any point, if I say d3fx by dx cube, then it will become tensor matrix in multiple variable case. If I say d4fx by dx4, it will become tensor matrix. It will become tensor matrix in the multiple variable case. If it becomes so on. So up to dual order derivative, it is Jacobian or Hessian. Third derivative onward, it is called tensor matrix. Or so order tensor matrix of order 5 means d5 fx by dx5. That is the tensor matrix. Okay, thank you very much. Okay, what is the concept? We have talked so much about the tensor matrix, Hessian matrix, Jacob. Little bit I'll talk about the realistic picture. The realistic picture of something called a Newton's formula. Okay, realistic picture in the Newton formula as far as Hessian matrix is concerned and Jacobian matrix. People can think more about it, but this is how it is. Okay, it may involve bigger thing also. But right now, we will try to find minima. Okay, this is the what concept. Idea was something else also. What the idea was, how to generalize a multiple variable derivative. Okay, not saying it is Jacobian, not saying it is Hessian, not saying it is tensor. In a generic manner, how I can represent a Taylor series through the any generic algorithm. Taylor series is fx equal to Taylor series is fx equal to fx means equation of any curve. Fx equal to fx at x equal to a. This is the constant term, always constant. Plus dfx by dx at x equal to a, constant, into x minus a. This will give a equation of a slant line. Okay, one function, one variable function, plus d2fx by dx square, d2fx by dx square at x equal to a divided by factorial of 2, a constant, into in bracket x minus a whole square, x minus a whole square, means this will make a curve. This is x-axis, this will make a curve. X square means it will make a curve. Okay, and so on. So Actually, if I say fx, then fx is first is constant that I can leave. Otherwise, it has set of functions as independent component x in varying degree of polynomial. Okay, this is the concept how I can describe this as a in a vector form or whatsoever, so that it will look. See, if I say a equal to 0, then if I come back to the Maclaurin series and I say Taylor series will become Maclaurin series when a equal to 0, then fx equal to fx at x equal to a is 0, fx at x equal to 0, plus dfx by dx at x equal to 0 into x plus d2 fx by dx square at x equal to 0 into x square plus d3 fx by dx cube into x to the power 3, okay, at x equal to 0, and so on. Okay, this is single variable. If I talk in multiple variable, then first dfx by dx will become Jacobian matrix. D2 fx by dx square will become Hessian matrix. D3 fx by dx cube, D4 fx by dx4, and so on. All these will become tensor matrix. And tensor matrix is a multiple dimensional matrix. Okay, first tensor matrix will come in if independent variable is x and y. It will come in 2 by 2 by 2 matrix. 2 by 2 by 2 matrix. If I talk about the fourth order tensor matrix, it will come 2 by 2 by 2 by 2, 4 times. If there are independent component is 3, then fourth order will be 3 into 3 into 3 into 3, 4 times. If it is a tenth of the d to the power 10 fx by dx to the power 10, then tensor matrix of the three independent variable will be 3, that matrix will be 3 into 3 into 3 into 3, 10 times. Means just think that how complex. Just try to multiply two matrix 3 by 3 or 4 by 4. How complex it will be. Just think that if you try to multiply two matrices, one is 10 by 10 by 10 by 10 by 10, sorry, 3 by 3 by 3 by 3, 10 times. 3 by 3 by 3, 10 times, try to multiply the matrix. I am 100% sure that no computer can do right now. You no GPU, no TPU, no one will do. You have to have a assembly. You have to have a cluster of GPU or TPU where hundred or thousands of the items are there in the cluster. In that cluster, they will be able to calculate these kind of multiplication, and that is required for the artificial intelligence based calculation. So these these knowledge are important. The main concept is if I have a single variable Taylor series where everything is in a constant into x, constant into x square, constant into x to the power 3, and so on. Can I bring it into multiple variable case where again we will have in a format of x1. Okay, it is other thing that x will become x vector here. Okay, research are going on so that people need not deviate. If anyone is thinking about a formula, then if it is 2D, if it is 3D, if it is 4D, if it is 5D, if it is 6D, if he is proceeding like this, then so it should not be like that. It should be generic. Does not depend upon it is single variable, dual derivative. That was the concept. Anyway, little bit we will try to see the concept of a Newton formula to find the minima in 3D. Okay, what is the Newton formula? If you have a function called f in bracket x bracket close fx equal to 0, then what is the value at which this fx will be 0? Very famous example, I always take consider fx equal to x square minus 2. What is the value of x at which x square minus 2 will become 0? Someone will say it is same as x equal to square root of 2, means x is the square root of 2. Anyway, x square minus 2 equal to 0, x square minus 2, I can claim it is function over x. Tell me the value of x at which it will be x square minus 2 will be 0. A square root of 2, a square of 3 will not work. You have to tell me exact in decimal what is the answer. If I go by Sir Newton formula, then it is x minus fx divided by derivative of fx, where x or function over x at any x equal to x or derivative of fx at any x equal to x, it depends upon your assumption. First, you have to make an assumption considering at this point fx will be 0, and that assumption you have to place this in equation and see what is your output. If I make that at x equal to 2, x square minus 2 will be 0. You place it here. X equal to 2 minus fx at x equal to 2 divided by derivative of fx at x equal to 2. Makes sense? Numerator fx at x equal to 2 will become 2. 4 minus 2, 2. Denominator will be, derivative will be 2x, 4. 2 by 4 is 1.5 and this side 2. 2 minus 0.5. What it tells? 2 is your assumption that at which fx will be 0. 2 minus 0.5. 0.5 is the delta error in your assumption. This is what Sir Newton is saying. If you have a formula like x minus fx by derivative of fx, means fx by derivative of fx is delta from the x where you have the error. So someone will say whatever you had thought that 2 is the solution. Okay, solution is actually 0.5 away from the 2. 2 minus 0.5. So 0.5 part, that is fx by derivative of fx, is called error part, deviation part, digression part. This digression should be 0. If it is 0, this delta x is 0, then whatever you had set x, that is the answer. Anyway, next question is, if I have fx equal to fx, I have fx as a function. Can you tell me when this function will attain the critical point, minima or maxima? Then someone will say it is very easy. Do one thing, calculate the derivative of fx and set the derivative of fx equal to 0 and find the value of x at which derivative of fx is 0. This is the critical point, and this critical point is considered as either maxima, minima, or the saddle point. Okay, so if I say when this will be minimum, x square minus 2, when it will be minimum, then someone will say do one thing. X square minus 2, fx equal to x square, if I draw, it will draw a parabola. Just a parabola. Minus 2, it will come down to. Understand? So the equation is, okay, this is x square, this is origin. This is x square, this is origin. This is x-axis, this is origin, and this is x square. If I say equation of a parabola is x square, this is the equation of parabola x square. If I proceed in positive x, it will go up. If I proceed in negative x, it will go up. X square minus 2. Whatever height you are calculating, it will go down by 2. I believe it makes sense. It will go down by 2. When x equal to 0, it will be minus 2. Makes sense? When x equal to something, then it will be this height. That will be 2 less. It will have a down little bit. X square plus 2, whatever we are calculating, it will go 2 up. Makes sense? Okay, someone will say, what about x minus 2 whole square minus 2? Makes sense? I have a parabola equation is x square. This is the parabola whose equation is x square. This is the parabola whose equation is x square. This is the origin and whose equation is x square. Okay, if I say x square minus 2, it will go 2 down. X square plus 2, it will go 2 up. Whatever, if I, instead of x, if I write x minus 2, x minus 2 whole square, bracket close, minus 2, then it will, same thing, x square minus 2 whole square minus 2. X square minus 2 means it will shift to right hand side. Makes sense? If I place inside x minus or plus, it will make shift along x axis. It will make x shift right hand side, x minus 2 whole square, and then minus 2, then come down. Okay, these are the intricacies of mathematics. If I say I have fx equal to x square minus 2, take derivative of x. If you take derivative of it, it will become gx. dfx by dx is gx. Gx is 2x. Gx is 2x. When Gx will be minimum, at what is the point, when Gx will be 0. I'm trying to find when fx equal to x square minus 2 will attain a minimum height or maximum height or saddle point. Saddle point means at that point, if this is the origin is the saddle point, at that point it is changing the direction like this. This is the saddle point. It is changing the direction. It is going up. It will coming flat and then going up. It is more or less here. Means here there is no slope. That's it. If there is a minima, then at this point there is no slope. There is a maxima. At this point there is no slope. Or saddle point. Saddle point is like this. Then again here there is no slope. There is no slope. Anyway, in no slope zone, your derivative will be 0. So 2x will be 0. In that manner, x will be 0. At x equal to 0, you will see minimum, maxima or whatever critical point. How to find it? Now to find it, first you derive fx with x, you get another function as gx. Whatever you are getting gx, now you have to find x for which gx is 0. Makes sense? Now if I say I have a function called gx and I have to find x for which gx is 0, I can reapply Newton's formula. And to reapply Newton's formula, I write it again. X minus gx by derivative of gx. Makes sense? X minus gx derivative of gx. If I do like so, then I will find a value of x at which gx will become 0. And this is the criteria for the seeing it is the maxima, minima or saddle point. Critical. Okay, understandable. If I break it, it will become x minus derivative of fx divided by dual derivative of fx. Now let's see the enjoyment. Okay, this is a very big enjoyment I'm talking now. X minus derivative of fx divided by dual derivative of fx. You have to find x. You have to find x for which the right hand side, that is single derivative of fx by dual derivative of fx, will become 0. Will become 0. So that there won't be any deviation in what is the point you have thought it. Understand? X minus single derivative of, x minus fx by derivative of fx, if second term is 0, means you are getting value of x at which fx is 0. Makes sense? If I say x minus gx by derivative of gx, and if you find a value of x at which right hand side becomes 0, then you are getting a value where value of x at which gx is 0, and actually gx is first time derivative of fx. Means if I find x at which gx is 0, means I am finding x at which derivative of fx is 0, and that is the critical. So to have the critical point, x minus gx by derivative of gx, I have to find for which x minus gx by derivative of gx. Full, if I calculate, it will become x1. And if it becomes x only, then right hand side should be 0. If I break it, then x minus single derivative of fx divided by dual derivative of fx. Makes sense? Now see the enjoyment now. Okay, if consider this is x-axis and this is the curve, this is the curve. Consider this is x-axis and this is the curve. This is x-axis and this is the curve. Now, if this is x-axis, then this side is minus x-axis. This is x-axis. Now, I take any point x equal to minus, probably x equal to minus 2. This is x equal to 0. This is x equal to positive. This is x equal to 0. This is vertical. If this is x equal to 0, then this is x equal to minus 2. At this point, if I try to calculate the gradient, then gradient will be negative. Gradient is positive. Gradient is 0. So gradient will be negative. Makes sense? If gradient is negative, what about dual derivative? Single derivative is negative. Dual derivative will be positive. If single derivative is negative, dual derivative will be positive. Understand? Anyone can try. Okay, means at minima, dual derivative will be positive. Anyway, we are leading towards minima. So if I now we have to find a value of x at which we will find the minimum value. Actually, answer is 0. At 0, we are attaining the minimum, but we will try with x equal to minus 2 from here. If I try this in the Newton formula, x minus derivative of fx divided by dual derivative of fx, next x what we will get after this calculation should proceed rightward. So that because we are leading towards x where the fx is minimum. If I start with here, then then we will calculate the derivative and dual derivative at this point, and then x minus that will give another x, and if this is the where I had tried, this is the origin, then next x will start moving toward the origin. If I try here, the next x will start moving toward the origin. That is the concept. Makes sense? This is called gradient descent. Gradient descent means the gradient. Okay, we will talk more now. Exactly gradient descent. Anyway, now the answer is if gradient at any point is negative. If gradient is negative, then dual derivative will be positive. In that manner, x minus negative by positive, x plus something you will get. This proves that x will start moving toward the origin. This proves that x will start moving anti, opposite to the gradient. If gradient is negative, x will start moving positively. Makes sense? If I try right hand side, if I try right hand side, okay, this is this is left hand side. If I try right hand side, then here the gradient will be positive. X minus positive, x minus positive. Okay, x minus gradient will be positive. X minus positive divided by dual derivative. Okay, consider dual derivative is positive again. Okay, consider dual derivative. Someone will say this side positive, this side positive, this side single derivative is negative, this side single derivative is positive, this side dual derivative positive, and this side dual derivative should be negative. No. Your dual derivative will be always positive if you are leading toward the minimum value. So dual derivative will be again positive. Now in that manner, if I have taken x, if this is origin, this point is origin, if I take x as plus 2, okay, in that manner, the gradient will be positive, dual derivative will be positive, x minus positive by positive means x will start decreasing, means x will start moving in the opposite direction of the sign of the gradient. Makes sense? Okay, x will start moving opposite, anti to the sign of the gradient. If this is x-axis and this is the curve, then if I take x in this direction, then after Newton formula calculation, x will start decreasing. Why it will start decreasing? Because gradient is positive. If I take negative side, gradient is negative and x will start increasing. X will go exactly in opposite side of the gradient. Okay, this phenomenon what I am talking now, this is called gradient descent. Gradient descent means when x, the x what you are calculating, new x what you are calculating, if it is going opposite direction to the gradient, then this concept is called gradient descent. Means gradient descent means x will start moving toward the place where you have minimum fx, where you have where you have minimum fx. Anyway, now the what I believe it is understandable. Okay, Now we will try to have an example. Whatever example I took, probably I'll proceed in that example. So if I have x square minus 2, x square minus 2, what is derivative? Derivative is 2x. X square minus 2, derivative is 2x. Yeah, derivative is 2x. If I calculate dual derivative, then it is 2. Can someone see? Dual derivative of fx as x square minus 2 is always 2. This proves that this curve does not have maxima. When dual derivative is constant 2, means it has minima 1. That is for sure. Now, if I'm trying to find x minus single derivative of fx divided by dual derivative of fx, dual derivative is always 2. Then it will come 1 by 2. Fx minus 1 by 2, 0.5. This 0.5, whatever I'm saying 0.5, this is constant. So x minus 0.5 derivative of fx. This is called step vector. 0.5 is called step vector. Step vector means if I'm at any x value, consider this is the equation fx x square minus 2. This is x-axis, this is origin. If this is the case, then I am at any point x equal to a. At any point, there I have made the first assumption. From there, I will provide a step function. Step function means I will try to move 0.5 right hand side and then try to calculate the new x. Makes sense? Okay. First x I will make an assumption. So what is the assumption? X equal to 2. I believe at x equal to 2, I will see the minima of fx. Not fx will be 0. Minima of fx at x equal to 2. If I place it here, it will become 2 minus 0.5. 0.5 is called step vector into derivative of fx at x equal to 2. That is 2x. 2x at x equal to 2 will be 2x at x equal to 2 will be 4. 4 into 0.5 will be 2. 2 minus 2. 2 minus 2, it will be 0. Okay. 2 minus 2, it will be 0. Okay, what we want? We don't want 0 here. We want it should be 2. If I have placed 2, then it should be, output should be 2. So that we know that we have got the solution. But it is coming as 0. I'll try again. X minus 0.5 derivative of fx at x equal to 2. X square minus 2 derivative of fx is 2x. At x equal to 2, it is 4. 4 into 0.5, 2. Means from 2, we are getting error of 2. You have made a big error. Okay. So this is called 0.5 is called step vector. Now, if my assumption is that minimum point is x equal to 2, where minima is x equal to 0, minimum point is x equal to 2. Now, from here, I'll try to move a 0.5. Okay, this is called stepping step. I make a one step and then I try to see what will be the error I am getting. If I make step as 0.5, the error will come as 2. 2 minus 2 is 0. Means if I had taken 2 as my assumption, the error is 2. Means x will start moving negatively. This is called gradient descent. Now, gradient will be lesser. At this, gradient is steeper. Gradient has to come to 0. So gradient descent means what I will do, that gradient will start decreasing. So gradient will descend in this manner, where x will start moving toward the minimum gradient. Anyway, now we are getting x equal to 0. We will try again. 0 minus 0.5 into 2x 0. Error is 0, means we have got the solution. This is called you move step by step and try to understand the new x value. This is also called x plus h. What is the new value of x is x plus h at at new step function. So if you make h as a step, x plus h or something like that. Anyway, I think we will proceed on this. Okay, I was ready with the 3D also. Okay, so this is a 3D shape equivalent to the what parabola we talked about. Okay, so if this is a 3D shape, then how we will proceed calculating the minimum point in 3D shape through this step vector and so and so. So probably we will proceed upon this. I believe it is interesting. Anyway, please don't mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone.